Okay, hi guys, welcome to our channel. So in today's video, we'll be exploring the second part of visualization. Today, we'll be looking at some of the bivariate analysis, which we were talking about in the previous video. Right? In the previous video, we talked about univariate analysis. We discussed some of the plots. So today, we'll be looking at analyzing two variables at a time. Okay, so let's first import all the necessary libraries. After importing all the necessary libraries, I will read the data frame or the data set. We'll start off with simple data sets relatively because we don't want to rush through things. Okay, I imported Seaborn 2 times. Pandas as PD. So IRIS dataset is fairly very popular, right? It's a data set which we typically use to learn basic concepts, and it's very easy to teach as well. Slowly and steadily, we'll move on to much more complex case studies, guys. So df.d types, if I do, we'll get all float and integers. However, we have a species column where it says that it is, it's an object column, right? So if I want to check the species dot value underscore counts, this will try to give me the number of counts of each of the labels in this particular column or categories of this particular column, right? Okay, so there are 3 different labels and each of them has 50 counts, which means that my shape has 150 observations. So in the previous video, we already discussed about univariate analysis, right? Where we try to plot a histogram for all the float type data, whereas for integers or species type data, where it is object, we try to plot the count plot. Now let's try to understand bivariate. Now, how do you do bivariate? Bivariate means understanding 2 columns at a time, right? So those 2 columns can be that both of the columns can be continuous. Yes. It may be that one of them is continuous and the other one is discrete or categorical. I write it as categorical. Okay. Or it can be that both the columns are categorical in nature. So you have 3 types of conditions. One is continuous, one is continuous categorical, and other one is categorical. Now, in these conditions, if I want to plot a continuous, what kind of plot will I use? So based on these 3 different combinations of these 2 columns, my plots will change, right? For continuous, what do? We typically look at scatter plot. Right? We try to find out any kind of correlation if it exists. Now, correlation is a concept which we'll try to cover in statistics again. Okay. But for now, it's important to understand what is a scatter plot. Once I plot it for you, you'll get to understand easily. The continuous categorical, what kind of plots do we use? There is something which is called as the bar plot in Python. Now, I understand count plot and bar plot are slightly different in Python. Okay. Count plot inherently will calculate the count of each of these, each of the columns, right? Of each of the categories rather of the particular column. So count plot will inherently capture or calculate the count of different labels or categories inside a particular column, right? Whereas bar plot is basically, you'll ask you for an X and a Y. Either one of them is a categorical value and the other one is the a numerical value, basically so let me try to explain in a much more simpler way. Suppose you have this is a count plot. So if I do count plot of species, it will automatically find out that there are 3 categories and each of them, one of them has 50 count. All the bar diagrams will have the same height, whereas a bar diagram is different. It will ask you for X. What does X stand for? Is it a label? It has to be a label, and against it, it wants a number. Okay, that is how the number, the count has to be provided by you. That is what a bar plot stands for. But in many cases, we can use it to do bivariate analysis. How? Especially with continuous and categorical. You can ask, using bar plot, you can ask the plot to give you the average value of, or the median value of all the labels of your categorical column. So if you have, by using bar plot, what you can do is you can ask the plot to give you the average value of that particular continuous column with respect to the category which you are plotting. So basically, suppose I have C1, C2, C3, and this is Y, which is a continuous value, right? So with respect to C1, what is the average value of, say, X2? This is X2 and this is X1. With respect to C2, what is the average value of X2? With respect to C3, what is the average value of X2? It's very similar to doing group by. When you do, suppose what I have to do here, df dot group by of X or X1, whatever it is, and do dot mean, right? That is what it means. Same thing will be done by bar plot. I'll show it to you during plotting. And categorical is very simple. We can do using stack bar plot, group bar plot. Okay, something which looks like, I think you guys might have seen, right? Something like this group bar plot, where you have two categories, right, for each of these bar diagrams. So we'll try to do that as well. Okay, now let us pick up the continuous features. So what do I have to do? df dot d types, and here also I'll do df dot d types equal to float 64. Correct, and I'll do dot index dot to list to extract the column names. These are my float columns. Okay, so let us pick up sepal length and sepal width. Okay, so I'll do df of, how do I do plt dot sns dot scatter? Let's see if it works. Sns dot scatter plot. So you can see here that, okay, so let's say scatter plot x is equal to sepal length, y will be equal to, let's say, sepal width. Okay, and then, so what is sepal length and sepal width? I can help you explain this with a diagram. Now, if you look at this diagram, this is a petal, whereas this is a sepal. So with respect to that, the width and the length, that is what we are trying to see. All right, let's try to understand that, some kind of relationship between sepal length, and let's pick up petal length as well. Okay. So once I do this, I also have to let the machine know the data which I'm talking about is from df. Let's see. So you can see here that my sepal length and my petal length, and as the sepal length is increasing, my petal length is also increasing, but for these set of data points. Now, if you look at this, for these set of data points, it's as if that with the increase in sepal length, my petal length is also increasing, right? But for these set of data points, with the increase in sepal length, my petal length is not changing much. It's not changing much. So maybe because they belong to different varieties of flowers or plants, whatever you call it, because we have got 3 types of different flowers or plants. So can I segregate these data points with respect to these 3 categories? It will be very interesting to understand that, right? Let's see. Now, if I look at the function here again, so there is a parameter which says hue. Okay, let's see if we can use this somehow. If I simply make this hue is equal to species, so you can see here that we get the segregation of all these data points with respect to these 3 different categories of or species of flowers. And I told you, right, because it's showing a different pattern, this may belong to a different species. So Iris setosa is following a completely different trend than Iris versicolor and Iris virginica. And it seems that Iris virginica seems to have a higher length, because most of these data points are concentrated, most of them are concentrated towards the upper right corner of the graph. So many insights you can draw, guys. And this is almost like a multivariate analysis, because not only we are trying to analyze petal length and sepal length, but we are trying to segregate them with respect to different species, so that we can understand at a much more general level. So now I have taken two columns, these two particular columns, right? So like this, I can make many number of combinations. So we have 4 different columns with float type, right? So I can make different combinations of all these columns. Now, will I keep on doing this repeatedly? If I have a function which will allow me to, make all the combinations and plot the bivariate analysis at one single go. So I have a function which is called as sns.pairplot. Now, please understand, guys, this particular function is typically meant for continuous values. Okay, so if I do sns.pairplot and the same exact syntax, there's nothing much to do here. Df, we all have to specify is data is equal to df, comma, hue is equal to species. Let's see if this works. Now let's see what we get. Okay, we already have an ID column here, which we do not actually need because ID does not provide any information, right? So if you, if you look at the ID column here, if I do df.head, and if you look at the ID column, it's just 1, 2, 3, 4, 5. It doesn't make any sense. So what I'll do here is I'll remove the ID column right at the beginning. So what I'll do here, I'll remove it here itself. How do I remove it? df is equal to df dot drop of ID, comma, x is equal to 1. And I'll again run all. Once I do that, and if I go down below, pair plot takes a little bit of time because it does all possible combinations of the various columns. We have 5 columns here, but when I look at the plots here, like if you look at the column names, I can only see the numerical columns. I do not see any column with object type of data or string type of data. That is what pair plot does. So first of all, what you need to note down and understand is that pair plot works only with numerical data. It may be integer, it may be float, it can be continuous, it can be a discrete integer also, but you'll still plot it. But if the column is of string type or object type, it will not use it, because there are 2 kind of plots which happen in pair plot. One is the distribution plot, and the other one is basically a scatter plot. How many diagrams do we have here after we plotted? We had 5 columns. Of course, 5 columns cannot be considered for pair plot because this one is an object column. Let's consider 4 columns, right? These 4 numerical columns. What did it do with it? So you can see it's 4 columns here and 4 rows here. So 4 cross 4, 4 cross 4. If I would have had 5 numerical columns, I would have got 5 cross 5. If I have 10 numerical columns, I would get 10 cross 10 matrix of figures. What does 10 cross 10, 4 cross 4 mean? It simply means all possible combinations of the columns. So the easy way to understand this is x1, x2, x3, x4. And again, you take x1 because we're doing bivariate analysis, right? 2 columns at a time, correct? So if I want to combine this with this, all possible combinations, how will it happen? X1 like this. So 4 possible combinations for x1. Similarly, there will be 4 possible combinations for x2. Similarly, there will be 4 x3 and 4 possible combinations for x4. So 4 multiplied by 4 times is 16 possible combinations. This is all possible combinations, including repetition. But x2, x1, I can understand. x3, x1, x2, whatever I can understand. It could be a scatter plot, right? If both of them are numerical. But what about x1, x1, x2, x2, x3, x3, x4, x4? Both of the columns are same, right? And we'll simply get a straight line because y equal to x, y equal to mx plus c, here it will be y equal to x, exactly, it's the same. It doesn't make any sense plotting a straight line. So what we'll do here, instead, the machine, what it does it do? It will simply give you the distribution of x1, a univariate analysis. Distribution of. So across the diagonal, you will see all the univariate analysis of the individual columns, all the distributions plots of the individual columns, because there is no point in plotting one column against itself, right? So sepal length on the row wise, you can see here, and below if you go, this is sepal length, right? So which means that on the y-axis, we have sepal length, x-axis may be sepal length here. So there is no point in plotting it. So let me remove the species here. I think the species we'll go to that. Let us plot a very simple pair plot first. If I simply do SNS of pair plot, data is equal to df. But here I've not segregated all the data points into separate species. I've just done the simple pair plot, right? Now, if you look at this for this particular first figure, what does it mean? It simply means that my y-axis consists of sepal length and my x-axis, what it is there, you have to go below and check it out. It is again sepal length, of course. So all the diagonal values, whatever they are, will have what you call as a univariate analysis, because the same column will be plotted against itself. Whereas rest of all the other diagrams will have scatter plots. Now for this, my y-axis is sepal length, which already mentioned here. Whereas if we go below, my x-axis is sepal width. So it's length versus width. That is how you have to check. So instead of plotting all these diagrams repeatedly, we can directly do it using a single line of code. But yes, as I mentioned, there will be repetition of figures, because somewhere it will be x1 versus x2, and again it will be x2 versus x1. Now, if you go below, like if you look at the mirror image of itself, you can see now my y-axis is sepal width, whereas my x-axis will be sepal length. You can see here. This is x-axis sepal length. Sepal length is here, x-axis, and this is my sepal width. So these two diagrams are, we have reversed the axis. So if you look at the entire diagonal here, either you look at the upper triangular matrix or we look at the lower triangular matrix. Now, if I want to segregate all these figures based on the species which I have with respect to a categorical column, I can do simply using Hughes equal to species. Now here you could see that certain data points are following a different pattern, right? Different behavior altogether. Here also you can see here, this is following a different behavior. This part, again, this certain different behaviors I can see here. And this is always because we have different species, maybe because of different species. Now, if I do Hughes equal to species, it will segregate those data points based on that particular species. And here you can easily see Aedes setosa seem to have a certain different properties, which is evident from each of these figures, right? Whereas versicolor and Virginia seems to follow some of the same pattern, but again, your Virginica is always on the higher side, whether it comes to radius, whether it comes sepal width or sepal length, or petal width or petal length. So this is how we can understand. And this is how it will help me solve the bigger picture. If I have all these properties, if I have all these 4 properties, can I make the machine understand, or can I make the machine automatically predict what kind of species would this particular plant belong or flower belong to? This is called as classification in machine learning. And by looking at this picture, I'm pretty much confident we will be able to make a good model, because we are getting patterns from the data. Patterns is what help us in making predictions. Now, if I have a function which is called as df.corr, that also works for only numerical columns. Okay, correlation is a numerical concept. It basically tells you what kind of relationship, what kind of linear relationship does it share? What does linearity mean? If there's a linear increase in x, there's a linear increase in y. Suppose we have 2 axes, let's say x1 and x2. If x1 linearly increases, my x2 also linearly increases. That is what it means. Okay, but we'll get to that in much more detail in statistics. But that correlation also gives you the same kind of description. All along the diagonal, you will get all the the univariate analysis. Actually, when you say correlation is 1, it means both the columns have the exact same values, because there is no difference between the two, right? It follows a straight line, exact straight line. That is why it's 1, 1, 1, 1. 1 means the highest correlation. There is a very strong linear relationship, the stronger linear relationship which is possible. -1 means, if one is increasing, the other one is decreasing. We'll get to later on, but you can see here as the correlation is high, which means that the scatter of the scatteredness of the plot is less. So if I draw a diagram like this has less scatter compared to something like this. Now I want to show you one more example. Here, when we try to plot, petal length against sepal length. We saw here there seems to be a linear increase, almost like a definite increase, not perfectly linear, of course, but yes, there was some kind of an increase in petal length as the sepal length increased. But when it came to Satosa, my sepal length was increasing, my petal length hardly increased. So for these data points, my correlation will be less. But for these data points, my correlation will be high because the relationship is stronger in these for these two particular species. So the scatteredness of the graph, the dependency of one column with another column. Why are we doing the scatter plot, first of all? To see how these two columns are behaving with respect to one another, right? Okay, and if they are behaving in a particular way, there should be a pattern which are visually visible from the graph. It can be exponential, it can be linear, it can be anything. But if it is uniformly scattered, there's not much relationship within the two, right? And if the relationship is less, I'll have a very low correlation value, which is closer to zero, right? Negative 0.42 means that if one is increasing, the other one is decreasing. Okay, so we'll dig into correlation in greater detail in statistics. But to just give you an idea, that is the purpose of a bivariate analysis when it comes to continuous and continuous plotting.